Hi, I'm Ren Shashalina binti Ramlan, matrix number A8200991. I am one of the members from Group 3. I will now start the presentation with introduction. Solid mechanics is a field of physical science that studies the deformation and motion of continuous solid media under external laws such as forces, displacements, and accelerations that cause initial forces in the bodies, temperature changes, chemical interactions, electromagnetic forces, and so on. Solid mechanics may be described as a field of applied mechanics that studies the behavior of solid bodies under varied loading conditions. Mechanics of rigid body, or simply mechanics, and mechanics of deformable solids are commonly separated into two streams. The basic theory of continuation solid mechanics is founded on two foundations: the basic law of motion that describes the equilibrium of a continuation body under external loadings, and induced interior forces. The purpose of this study is to analyze the concept of the chosen topic, which is torsion. Torsion is the twisting and wrenching of a structure caused by forces, which results in rotation motion in one longitudinal axis, while the other spins in the opposite direction. Torque in torsion produces a stress dispersion across the cross-section, while other axial loads produce a constant or average stress across the object's cross-section. Without noticing, the use of torsion in daily lives are countless. Torsion force contributes to a vehicle's smooth and seamless movement. Torsion springs are utilized in a vehicle's chassis, gearbox, clutch, suspension system, and other components. Other than that, the concept of torsion helps when it comes to opening a bottle of cap. The cap will be opened while the twisting force is given by the twisting the bottle cap while holding the bottle body in place. Pure tension occurs whenever a bar or shaft of a circular section is twisted by a moment and the deformed element is in a condition of pure shear. In torsion analysis, just a few assumptions are taken into account. The shaft longitudinal axis stays straight. The shaft doesn't grow or shrink in length. As the cross-section rotates, radial lines stay straight and radial. Cross-sections rotate around the member's axis. The right-hand rule also can be used to link torque direction to rotation direction. The shear modulus, also known as the modulus of rigidity, is a measurement of a material's rigidity while it is in a shear, which is twisting. The polar moment of inertia is determined by the diameter of the beam. Torque is a force proclivity to spin the substance to which it is applied. The magnitude of the part of the force vector that is located in the perpendicular plane to the axis is also the torque. Other than that, torque is done by multiplying the shortest distance between the axis with the direction of the force component with respect to the axis of rotation. Shear stress is a force that tends to deform a material by causing it to slide planes parallel to the applied tension. The shear that results is extremely important in nature, since it is linked to the downslope motion of Earth and the earthquakes. Shear strength is defined as a change in angle between two previously perpendicular lines. Assume an elemental area that will be distorted, resulting in angular shifts, yet the sides of the region remain roughly the same length.
Assalamualaikum. My name is Ismail bin Yusuf. I will explain about the methodology for this project. Okay. If the specification and status of the gearbox are known, wheel torque can be computed as a function of engine torque. In this methodology, we will figure out how to measure the wheel torque and force for the following situation. First, engine torque. Second, gear ratio. Third, final drive ratio. Then the last one, wheel radius. Now, I will explain about the formula that we use in this calculation for the project. The mathematical formula of the wheel torque function of the engine torque is obtained by substituting first formula for second formula in third formula for a given gearbox ratio Ix and a final drive ratio I0. For the second formula is the formula of the wheel force function of the wheel torque and wheel radius can be found in this formula. Now I will talk about the calculation. With the given values, calculate the wheel torque and force for a rear wheel drive vehicle RWD. First, engine torque 150 Nm. Second, gearbox first gear ratio Ix equal 4.171. Third, final drive ratio 3.480. And the last one, tire size marking 225/55R17. Now I will explain about the step for the calculation. First, calculate the free static wheel radius from the tire size marking. The method for calculating the wheel radius is described in the methodology how to calculate wheel radius. The calculate wheel radius is RW equal 0.33965 meter. Second step is calculate the wheel torque using this equation. 4.171 multiply with 3.460 multiply with 150 divide with 2, and the answer is 1082.3745 Newton meter. And the last step is calculate the wheel force using this equation. 1082.3745 divide with 0.33965. The answer is 3186.7349 Newton.
Assalamualaikum warahmatullahi wabarakatuh. My name is Izzuddin Mizanuddin. Now I will present about discussion. First, we use formula TW equal to IS times IO times TE divided by 2 from equation 6 in methodology to calculate the wheel torque. We use this formula or equation because we make the find all of the values given in the question and compare all of the equation given in the methodology. So to find a suitable equation to find the wheel torque. So TW equals IS times IO times TE divided by 2 is suitable for this method. Next, we use equation FW equal to TW times RW from equation 10 in methodology to calculate the wheel force. Same as before, we find all of the value given in the question and compare all of the equation in the methodology to find the suitable equation with the value given to find the wheel force. So from all of the calculation, we got some advantages from for this. First, we can find the better material to accommodate force and torque at wheels, because the materials used in the automotive industry maybe not to have a strength to accommodate with the torque at the wheels, so the manufacturer can make the drive shaft more reliable and more last longer. Also, the manufacturer can setting the car suspension according to the force and torque at the wheels, because for this from this calculation we can find the torque and the force at the wheels. So the suspension settings is compulsory to making the driving experience more fun and comfortable to the drivers and the passengers. From the advantages we got, we also have disadvantages. Then the disadvantages, we will have a research and development cost that will be high. That is because the time consumed and the money we use to find the better materials, doing research to find the better materials, to making the best drive shaft or crankshaft for the car, to making the driving experience and the car more reliable. The last one, the disadvantages is the material that we have need to be prepared and take a lot of time to making it, because some of the materials are not have many in this earth, so we need to wait or making the materials for a long time to produce the material. So the time consumed will be high, so the car production maybe will be slow to produce the car and deliver to the customer. For the conclusion, the torsion is a topic that very important subject in solid mechanics, because the topic is very useful in many areas, especially in automotive engineering. In automotive engineering, we need to find the torque at the wheels, the torque at the crankshaft, at the drive shaft, to making the best material to be used in all of the shafts and drivetrains. Because also the engineers will be able to update the material used for drive shafts and drivetrains that can be used in automotive area, because the automotive area is one of the area that very fast forwarding in modernity. Plus, today we don't also have internal combustion car. We also have electric cars. So the torsion topic is very important to making the drivetrains and drive shaft to the electric cars too, because electric cars also use shaft in their cars. For making a better drive shaft, we recommended to use aluminum alloy material, because the aluminum alloy material has a good mechanical properties and good weldability. Also, aluminum alloy is a lightweight material compared to other materials that used in manufacturing a drive shaft or drivetrain. Also, we recommended to use seat and sink turning process for making the drive shaft or drivetrain, because it can increase the production speed of drivetrain and drive shaft, and also cost effective and safer in industrial operation. For closing of this conclusion, we also hope the torsion topic will become major things in much application in engineering, not only in automotive engineering only. That's all from me. Thank you.